Hello students, this is Mr. Boyd. Welcome back to another lesson in algebra. Today's lesson is on solving a system of equations using elimination. So let's go ahead and jump right in. As we have already seen in previous lessons, a solution is an ordered pair that makes all the equations true. And an ordered pair is written as x comma y. So today we're going to look at elimination, but before we get into actually solving some systems with elimination, let's take a look at equivalent equations because we're going to use some of these strategies to solve systems. So the question here is, does adding two equations together make another equation that's true? Well, let's see if that in fact happens. So if I add the top equation to the bottom equation, do I get another equation that's actually true? So let's see, 3 plus 7 would give me 10. 5 minus 3, or 5 plus negative 3, would be 2. And then 8 plus 4 would give us 12. Now, is 10 plus 2 equal to 12? Is that a true statement? Well, it is. So what did we find out? We found out that if we add two equations together, we get another equation that's true. Let's take a look and see what happens if we subtract. Does it work the same if we subtract two equations? Okay, so if I'm going to subtract, I need to subtract each term. Okay, when I added each term as well. So let's see here. 3 minus 7 would be negative 4. 5 minus negative 3, let's see, that becomes plus a positive. That would be plus 8. And 8 minus 4 is 4. So here's the question, is negative 4 plus 8 equal to 4? Well, yes, it is. So this is a true statement too. So here in the first example, we see that addition or subtraction will give us an equivalent equation. Let's take a look at the second group. What happens if I add? 18 plus 5 is 23. Negative 10 plus 2 is negative 8. 8 plus 7 is 15. So again, we see this as a true statement. What about subtraction? 18 minus 10 equals 8 minus 5 plus minus 2 equals minus 7. Okay, so 18 minus 5, that would be 13. Negative 10 plus negative 2, that would be a negative 12. And 8 minus 7 would equal 1. So here's the question, is 13 plus negative 12 equal to 1? Well, yes, it is. So again, we see that adding or subtracting two equations gives us the same, gives us an equivalent equation, or another equation that's true. Okay, so does multiplying work the same way? Well, let's take a look. What if we multiply both sides of this equation by 3? Let's see, that would make this 15 plus 45 equals 3 times 20 would give me 60. Well, is 45 plus 15 60? Well, yes, that's true. What about division? Let's take a look at division. What if we divide? Is that going to give us a true statement? If I divide every term by 5. Let's see, that would give me 1 plus 3 equals 4. That again is a true statement. So here we've seen also that if we multiply or divide both sides by a common number, that we can produce an equivalent equation or another equation that would still be true. Okay? So let's roll on down here and do our vocabulary and jump into actually solving some elimination problems. So blank are two numbers whose sum is 0. We call those additive inverses. Additive inverses. So that would be like the number 3 plus negative 3, or 10 plus negative 10, or 2x plus negative 2x, or 4x squared plus negative 4x squared. All of those would add up to 0. Another reminder is that a coefficient, and the reason we define these terms is not so you can just fill in a test, but when I use this word in my instruction, you're not confused. Okay? So I wouldn't ask you to define what a coefficient is, but you definitely need to know it so that you don't get confusion on your face when I talk about it. Okay, so we've got 3 steps here to doing the elimination method. And the goal here is to use addition to eliminate one of the variables. Okay? So first we want to look for a variable whose coefficients are additive inverses. If the coefficients are not, then we're going to multiply one or both equations. Then the last step would be to use substitution. Okay? So let's see how those steps play out down here on some examples. So first off, I want to look at my variables. I've got an x and a y, and the first thing I notice is that they are lined up above each other, which they should be. In order to use the elimination method, we need to make sure that the x's and y's are lined up, the equal signs lined up, my constants are lined up, all in the same location in both equations. If not, then we would just rearrange the equation so that it does line up. Okay? Now, when I look at my x's, I notice that this has a 1 as a coefficient, this has a 3. Those are not additive inverses. Okay? Let's jump over to the y's. So I'm going to look at the coefficients on the y's. And I notice that the coefficient on the first y is negative 3, and the coefficient on the second y is positive 3. So I know from our definition of additive inverses that when I add those two together, I'm going to get 0, which is what I need in order to eliminate that variable. So let's see what happens here. Let's go ahead and add the top equation and the bottom equation together. So I've got 1x plus 3x. That's going to give me 4x. I've got negative 3y plus 3y. So I've got 0y. I got 7 plus 9. That's going to give me 16. Now we know that 0 times y is just 0 and that we don't need to write that down. Okay? So now I've really just got the equation 4x equals 16. Notice how I eliminated the variable y by adding those additive inverses together. As always, the next step is to divide by 4 because we want to isolate the x. 16 divided by 4 is 4. So the first part of our solution is 4. Yeah, now, how do you think we will find the second part of our solution, our y value? Well, you're right. We're going to do the same thing that we did yesterday or in the previous lesson, and that is use substitution. So I'm going to use this first equation simply because the x is by itself. I don't have to multiply that 4 times anything. I can just solve this equation. So I'm going to substitute the 4 in place of the x. Okay, and then solve this equation. So I'm going to subtract my 4 from both sides. That's going to give me negative 3y equals 3. And of course, the next step is to divide by negative 3. And that's going to finish up with y equals 3 divided by 3 is 1. A positive divided by negative is a negative. So my answer here is negative 1. Let's check it in the other equation and make sure. So, question is 3 times 4 plus 3 times negative 1, does that in fact equal 9? Let's put a question mark here to see. Okay, well 3 times 4 is 12 plus negative 3. Does that equal 9? Well, yes it does. So that tells me this is my solution. Okay? All right, so I'd like for you guys to go ahead and try the your turn. Pause the video, please. Give that one a shot and then check in later. Okay, guys, now that you've had a chance to do the your turn, I will post those answers in just a moment. But let's go ahead and move on to the next example. So in this next example, I notice I'm going to look at my x's again. Notice that my x's are lined up over x's, y over y, constant over constant. Okay? I notice that I don't have an additive inverse on the x term. I also notice that I don't have an additive inverse on the y term. So here's the question. Can I multiply one or both equations by a particular constant and end up having additive inverses? Well, of course we can. We can multiply this first equation by negative 4, because the opposite of 4 is negative 4. That would give me an additive inverse. So let's see what happens when I multiply that. And I will write it right below this equation. I'm going to do this one in blue so you can see it's the same equation multiplied. Okay, so this would give me negative 4 times x would give me a negative 4x. A negative 4 times 10 would give me a minus 40y. And then a negative 4 times 3 would give me a negative 12. So now I want to ask myself, do I have additive inverses here? And here I see that I do. I've got a positive 4 and a negative 4. And remember, we kind of designed it that way by multiplying by a number. Okay? So let's add these together and eliminate the x value, the x term. So 4 minus 4, that would give me a 0x. 5 minus 40 would give me a negative 35y. And I've got 5 minus 12, which is going to give me a negative 7. Notice once I multiplied this by negative 4, I'm no longer using this equation anymore to solve. Okay? We know that 0 times x is just 0, and we don't need to write that down. Okay? So let's go ahead and solve this. So now we're going to divide by negative 35. Okay? And that's going to leave me with y equals 1/5. Okay? So now I know that my solution includes a y value of 1/5, and I need to go find my x value. So to do that, I am going to use the first equation, x plus 10, and I'm going to substitute that y in there, 1/5 equals 3. Well, 10 times 1/5 is the same thing as 10 times 1 divided by 5. Well, 10 times 1 is 10. Divided by 5, that's just going to leave me with 2. Next, I'll subtract 2 from both sides. That's going to leave me with x equals 1. So let's see, does that work? Well, 4 times 1, let's check it in the second equation. 4 times 1 plus 5 times 1/5 equals 5. Well, 4 times 1 is 4. 5 times 1/5 is the same as 5 times 1 divided by 5. Well, that's just going to be 1. Does that equal 5? It does, so this is the correct solution. Okay, guys, we're out of time on this video. I will have a second one for the second part of this lesson, so tune in for that as well. As always, click the subscribe button, and if you click the bell, you'll get notifications whenever I put out new videos. Thanks for watching. Have a great day.